Welcome back to the off-grid garage in sunny hot Australia. I was hesitating a bit because can you hear that? If this gets too loud, let me know. It's the inverter. Charging the vehicle, pool pump is running, charging the battery, charging everything from solar. Amazing. Well, I guess you were expecting another video another day, so here it is. Here's the next video. We keep going, rocking the show here. There's more stuff to do, of course. So in this episode, we don't want to work on the bus bar or breaker situation. We go to the other side and we want to work on our 12 volt, 5 volt department here. I have briefly spoken about this before. Actually got this brand new DC to DC converter, an Orion TR from Victron. It is... What are you doing there? Yeah, or just ignore me. Okay. What is he doing now? What? Okay. Okay, that's unusual. Right. So we've got the isolated DC-DC converter. It's a 48 volt down to 12 volt, 20 amps. I originally wanted a 30 amp, but they are quite expensive and I really don't need a 30 amp probably for 12 volt. 20 amp should be totally fine. Ah, that looks exactly the same as my solar charge controllers here. That's the same case. Huh, look at this. Exactly the same case. Okay, so what do we have here? Input, output, positive, negative. And we've got a remote switch bridge. So you can take this out and put a little switch in between. You can remotely turn this one on and off. We've got an on-off light here. And here is a little screw inside. This is an adjustment screw for the output voltage, which can be regulated by, Hinweis. Wählen Sie einen kühlen, trockenen... What? Hang on. Select a cool, dry and ventilated area. I think it will be totally fine. Oh yeah, I wanted to look at the... Here it says it -15 to +25% of the default output voltage. So... 10 to 15 volts. There you go. And interestingly, the manual also says you can use this device as a float or constant voltage charger for your batteries as well. And you can parallel as many as you want of these. Yeah, it says it here, the output is overload and short circuit proof. The converters can therefore be connected in parallel and can be adjusted to float charge a battery. So perfect. Okay, I was going to mount this one here inside. Oh, it's a bit dark here. There, that's better. So I want to mount this one here on the outside of this panel. Well, in the inside of the cabinet, but outside of the panel. Well, it's the inside. It's the inside. I want to mount this one here on the inside of the shelf, probably like this. Well, then we go through a circuit breaker into the input here, 48 volts, and have 12 volt output. The 12 volt output from the converter goes then into our fuse box here. I will link this down below as well if you're interested. This is one rated for 48 volts. This is not a 12 volt fuse box here because it's assembled in Mexico. Yeah, that's the Blue Sea system fuse box. So we go in here, positive, negative, and then we've got all the negatives here bridged together, and these are our positive outputs, and they are fused with one of the little plate fuses, little car fuses then. And then we have a few loads here in the off-grid garage which are powered by 12 volt, and I want to power them directly from this inverter and not using single transformers, for example, all the time. See, one of them is our modem and switch Wi-Fi access point up here. This is powered by a 12 volt 1.9 amp power supply, but the device itself only pulls around 1 amp or so. a little bit more when it starts up, but afterwards 1 amp 12 volt. I have also bought this little cockpit thingy here. This is one of the modules going in is just a 12 volt outlet, like a cigarette lighter outlet, and the other two will be USB chargers. So I've got 2 chargers here in 1 module each. Where the hell are they? Here's one. Here's one. So they look like this. And they have an on-off button here on the side as well. And they are 3 amps each. So I will have, so basically something like this. 1 cigarette lighter and 4 USB ports here, all being powered by this converter here. And this is mainly for charging all these cameras here. Yeah, did you know all these videos here are made by 100% renewable energy? Even the cameras running on 100% renewable energy. Isn't that great? So that's what these 4 chargers. Look, there are always cameras charging here. I've got my mobile phone here. I've got the lights here, 12 volt. I've got the little tablet here showing the VRM all the time. So this is all powered, and I usually have occupied one of my outlets here with this USB charger just here. So I thought, well, just buy some of these ones. We can all charge and run this all from the 12 volt DC converter then. So this is the plan. This is the whole setup. Oh, no, there's more. I was lying. I've got this little guy here as well. So this will go into one of the switchboards here, and this is a DC to DC converter as well, from 37, where does it say? From 24 to 78 volts input, and the output is 5 volts and 3 amps. This is an isolated DC to DC converter as well. And this will be here for supplying power to our Raspberry on a safe and secure form, because it's isolated, and also supplies power to our Wi-Fi wireless bridge up there. This is powered by USB 5 volts as well. So this one and the Raspberry will be powered by this little device sitting here in one of the switchboards, then connected to a circuit breaker, connected to our main bus bar, connected to our battery here. All powered by 100% renewable energy, freshly made here from the off-grid garage in Australia. I've already marked where this little panel should go here. This goes up here in the corner and will be, well, because when this shelf goes into this gap there, the USB ports will be somewhere over here on this location, and this is easy for me to reach and plug in my cameras and everything, and then I can leave everything either here on the workbench or on top of the shelf there, just sitting there while it's charging. And we also have a 12 volt outlet. I thought, well, who knows, you know, we may have a 12 volt little fridge or something which we can plug in during summertime, because we have so much energy and we have so much thirst, so we need cold beer, we need a fridge, 12 volt, little compressor. I don't know yet what to buy. These ones are not good. They are, well, this is just a joke. This is 5 volt USB connected little fridge. The beer was 21° warm the other day. Undrinkable. I had to put the can back into the normal fridge and let it cool down. They are not working. Don't buy them. They are really, really bad. So something like this, these are my ideas at the moment. They may change, as they do very often, but we will see. So this is the main task today, working on this 12 volt, 5 volt conversion corner over here. And as I said before in one of my videos, we will have a separation shield in here to separate this part of the cabinet from the 48 volt bus bars here. Something like this, maybe a little bit higher or something. I don't know yet. We will work it out later on. Okay, let's mount this one here on the inside and then drill the holes for this little panel there. Then we're almost good to go. Oh yeah, and I've also ordered a smaller one of these fuse boxes with 4 fuses only for the 5 volt distribution then. We have only 2 loads connected to it at the moment, the Raspi and the Wi-Fi bridge, but who knows, in the future I've ordered one with 4. 2 are spare, 2 are future. As always, be prepared. Also guys, have a look at this. I drilled 2 holes down here. This is our circuit breaker here, DC circuit breaker, positive and negative. And I have crimped a ferrule onto this 35mm cable here. Okay, so we're coming through this hole. And then we have to bend it like this. I have to get fairly straight, and there, bang, look at this, it's in, it's all the way in, and look at the angle we get. So it will be like this. Once it's tightened, it will be like this. So there, I think that's not too bad, right? It's not too bad. A little bit of heat shrink over this corner here, over this gap, and we are done. I think that's a winner. See, I was always under the impression we have enough space here. It's like 55 millimeters we have from the circuit breaker to the bottom of the switchboard, and we have the same distance up here. So we can do the same. I've marked all the positions where the cables come through, and we just need to drill holes about 15 millimeters, and then we can feed in the cable and use these bootlaces here to connect the cables to the circuit breakers. It's a clean installation. We can have them red and black. I think that's a good solution here. And this is how the crimping looks like of the 35mm bootlace or ferrule. And I especially bought another crimper for that, from 10, 16, 25, 35 millimeters, and 35 is the maximum it can handle here. That's quite large. And because they are more than twice as long as we need them, I'll put the cables in first, crimp them, and then cut them off. This was suggested by someone under one of my videos, and that's actually a pretty good idea, and you get a very clean cut. I'm just using my normal cable cutters for that, and these fit perfectly into the circuit breakers. There. There's aluminium pieces flying around everywhere. It's not good. I don't know what happened here, but I've forgotten to tap into the aluminium sheet here. So the hole was already too large to tap M4, so I had to use some washers and nuts on the other side. I usually don't do that. I hate this. I always tap if possible. Yeah, put thread in there, done. Like here for the DC-DC converter. So, and here's my panel. Looks good. Yeah, I have decided to mount everything directly here on the side panel, because I will not be able to take this off anymore. It will be sitting there in the corner, and this metal beam is in the way, so we cannot take it off. We cannot reach any of these screws anymore unless we take out all the batteries and then slide this shelf forward a bit. Then we can access the screws, but once they are in now, they are in. That's a forever thing. Forever! So we've got 4 USB connections here, 3 amps each, and also a 12-volt outlet for a cigarette lighter now. And this will be connected to the DC-DC converter, which we are mounting right now. So hopefully my measurement was correct and the converter fits in there. this fits. Okay. So, and the screws are not peeking out here. They are flush with the panel, which is nice. I used some thicker washers here to make this work. They were just popping out a little bit here. USB chargers, 12-volt outlet, and the DC-DC converter mounted now. Perfect. Okay, let's continue with this one. Oh, here, before we continue, I want to show you something. Here. Look what I found. The M8 bolt of our main circuit breaker with the crimped on washer and spring washer. I found it. It was behind there. So this is all complete now, and it probably will replace this at some stage then. But I'm missing 2 screws of my smaller circuit breakers now, the M6. I've got only 4, but I need 6. I've got 3 breakers. And I should have 6, but I've got only 4. So 2 are missing. I looked everywhere. Can't find them. Here. I've got only 4 of them. See, these are the ones. 4 of them. So I must have put 2 somewhere. But where? I really cannot find them. 1, if you miss 1, well, this can roll away and misplace itself, hide itself somewhere. But 2, I have clearly put them somewhere, and, well, I don't know where. I'll find them eventually when we are finished, and I have replaced them with some other screws, I think. I've got only 4, I can't believe it. So I keep all the accessories now in this box here. All of them. Then I thought about, well, once the switchboards are in here, we cannot take off this panel anymore. So if I need access to the fuses behind here, I always have to take off the top cover here, the top floor, the roof, basically. That was always my intention, my plan, to have the roof on here, and I'll take the roof off and have access to everything. Well, remember, there will be a clear acrylic over these bus bars here as well, so they will not be exposed as they are right now. But here, for the 12-volt and 5-volt compartment, once we have the barrier in between here, I was thinking of maybe having a maintenance lid or something here from the front with a little lock or something, you know, just some nice looking little door we can open, and then we can get in and replace a fuse or have a look at the cabling, whatever we need to do. Adjust the voltage on the DC converter, something like this. What do you reckon? Would that be a good idea to have a little thingy here, or leave it as it is and we just use the top, the roof? We go through the roof like Santa, you know, it's that time of the year. We come from above. I mean, I'm not expecting to replace these fuses ever. You know, once they are in there as a 12-volt, unless you make a short or something, and but usually they should just stay there forever, and you would never have to touch them again. Never ever. I don't know. Let me know what you think. It's a community project, so let me know. Yeah, nice and steady. No problems drilling into this acrylic. We let this video go until here. We've done all the mechanical work, drilled all the holes, mounted all the devices now in the shelf here. And in the next video we can pull some cables and install this all here. Yeah, and now that we have found a solution to connect our circuit breakers here, we can even go further and make some cables to connect between bus bars and circuit breakers now. That'll be interesting. Okay guys, until the next video, probably tomorrow, maybe the day after tomorrow. It is Sunday after all. As always, I link all these devices here down below under the video and on my website if you are interested in this stuff. And until the next video guys, stay charged, and thank you for watching again. See you then. Bye bye.